My passion connects me globally with maths. We'll talk about polynomial division in this particular video. You can always contact me on the address given. We'll learn all these things about the polynomial division, starting with what are polynomials, how do we connect, relate, illustrate, so many different things. Naisha, a grade 8 student, is going to learn all these concepts with our approach, engaging minds. Our vision is look at the question and connect it with all the related problems. So there are so many ways in which we can apply the polynomial division. And here is our golden girl, Naisha, gold in archery, and now she wants gold in mathematics. Let us see if she can get it. Let's enjoy the lesson with
First in skipping,
Naisha.
second in standing broad jump, first in 30-meter dash, first in shuttle run, and second in long distance.
Hi, Naisha. How are you doing?
Hi, I'm fine. How are you?
Very good, very good. So, Naisha, today, what do you want to do?
We will continue the division of polynomials revision.
Yes. Good. So, you have an exam in 2 days coming up, right?
Right.
After the weekend. I want you to really perform very well in your exam. Let's do a review today. But before that, I would like you to introduce yourself to everyone who watches my videos.
Yes. Hi, I'm Naisha. I study in grade 8. I love sports. I have won gold in archery and I also won gold in maths. That's all.
Correct. So the golden girl with gold in archery now wants gold in mathematics. I'm going to help you. You'll surely get through all this, right? So let's begin with a review on what we have learned about polynomials. In this session, I'm going to ask you questions. I'm not going to teach you much. But while you answer those questions, I'll fill in the gaps and ensure that you can actually understand the whole topic and get the gold in mathematics also. Okay, so let me share with you a whiteboard. So from there, we are going to begin. And the idea is we need to do what today? What is the topic for today?
Division of polynomials revision.
Topic is division of polynomials, right? Okay, so first thing first, we have to figure out what are polynomials. So first thing is we have to think what are polynomials, then we'll think about division, okay?
Yes.
So I'm writing some expressions. You have to tell whether it is a polynomial or not. Is this a polynomial?
Yes.
Yes. So this is a polynomial. How about square root of 3x to the power of 3 plus square root, let's say half x minus 7. Is this a polynomial or not?
It is a polynomial.
Correct. And if I have x plus 3 square root of x minus 7, is this a polynomial or not?
It is a polynomial.
It is not a polynomial, right? So we understand that it is not a polynomial because of this term. Now, what in this term? The power of x is half. You see, x power is half, not a whole number, correct? So since the exponent of variable is not a whole number. Do you understand?
Yes.
It is not a polynomial. So what is important is to understand that if I write some expression with many terms, right? In that case, what are we looking for? We are looking for exponents of the variable. In this case, it was x. So we also say, so in any polynomial in general, we'll write a polynomial like what? Let me now write down a polynomial in general, okay? So let me write down what is a polynomial. So let's move to the fresh screen to understand what is a polynomial, right? So we are actually considering polynomial in one variable. Is it okay? For our class today. So we are talking about polynomials in one variable. We could have polynomials in many variables. Is that okay? But we are talking about polynomial in one variable. And we will write a polynomial in one variable as something y equals to an x to the power of n plus an minus 1, x to the power of n minus 1 plus an minus 2, x to the power of n minus 2 plus so on. And then we have ax plus we have just a a1 and let's say a0. Do you understand? So when we write something here where n is what? N belongs to. See, look, this time I have written as n belongs to integers, positive integers. Do you see this positive integers? Correct? So n
Yes.
belongs to positive integers. Is it okay?
Yes.
Positive integers. So now we could also say n belongs to whole numbers, right? So that is what the definition here is. We can say, we can also write here where n is non-negative. Integer. Is that okay?
Yes.
Because integers could be positive or negative and 0 also. Now, why n? In this case, do you see which we have written a0? It is actually x to the power of 0, right? Anything to the power of 0 is 1, correct? So that place I have not written n. How? In general, we will write it as a polynomial as a function of x. This is function notation, okay? Where it is sum of terms. This is new sign for you for higher level. an x to the power of n. Do you understand? Where
Yes.
n could go from 0 to let us say, now I will write some value m here. Is it okay?
Okay.
To some value m or r, right? Depending on how many terms are there. Is it okay?
Okay.
So let me write r here, a to the power of r, right? So if I write r here, then r is the highest power, correct? In the terms, correct? So you can put this series. So that means this series will have the highest power as r. So the highest power is called the degree of polynomial. So in this case, r will be degree of polynomial. Is that clear?
Yes.
So degree of polynomial is what? Degree of polynomial is highest power of any term. Highest power of x is the degree of polynomial. Is this part clear to you?
Yes.
Correct. And all these a's, they are real numbers. So an belongs to set of real numbers. Real numbers, you understand? Square root is a real number, right?
Yes.
Pi is also a real number, correct? So even if I write pi or e or these are real numbers, okay? They may be irrational, but they are real numbers. So, but n has to be non-negative integer. Is that clear to you? And the sum
Yes.
of these terms. So once again, let me rewrite this polynomial in function notation, right? So we also say this as polynomial is a function. So we'll say polynomial is a function. We say f of x is my polynomial, which is basically sum of an x to the power of n, where n is from 0 to r, right? Do you understand? So when I say that, then in that case, I am actually, let me expand this in standard form. If I expand it like this, I will write like this: a0 x to the power of 0 plus a1 x to the power of 1 plus a2 x to the power of 2 plus a3 x to the power of 3 plus so on ar. This is the rth term. Do you understand? X to the power of r. Now in
No,
this,
I'm not understanding how are we doing this.
correct. So sigma means sum of. Sigma means sum of. Sigma means sum of, right? And then what we do is substitute in each term the value of n as equals to 0, 1, 2 till r. You get the point?
Okay.
So when I substitute 0, I get a0 x to the power of 0, correct? When I write 1, I get a1 x to the power of 1. When I write 2, I get a2 x to the power of 2, x squared. You get the idea? This is x cubed. Now, this is what you have to learn in grade 8 also. I know you are in grade 8, but I'm preparing you for grade 11. So this is extended.
Okay.
We learned this once again in grade 11, but I want to teach you now to get the idea. So you have also learned what is sigma, right? You understand sigma? Sum, right?
Yes.
It is short form of writing sum. Is it okay? Sigma is sum, okay? It comes from letter S only. We'll have many different words, but let's just, you understand this? Now, very important thing for you to remember is that this series which I have written, which is sum of terms, should actually be written as highest power first. So, one decreasing order. Do you see I'm writing in decreasing order now?
Yes.
So on plus, we can say a2x squared plus a1x plus a0. Do you see? So when you write it in decreasing order, so now we are writing this in decreasing order. Decreasing order of terms, right? So R value is decreasing. Do you see R value? So order is order of the each term, right? Decreasing order of terms. This is called standard form of equation. In this case, polynomial equation. You get the point?
Yes.
So whenever you are given a polynomial equation or a function or an expression, it should be written always in standard form. That means highest power first and then decreasing. Okay? That is kind of important. And therefore, I went through these steps. So I've introduced you. What is sigma notation? Short form of writing such a long thing, correct? So let's
Yes.
clear this all and let me write down now. Another, so instead of function, I'm writing y, which you normally use. I'm writing here 2x cubed minus 3x squared plus 7x plus 5, right? Now in this polynomial, first, tell me what is the degree of polynomial?
Degree of polynomial like monomial,
Highest
binomial.
power,
Highest power is 2x cubed.
3. 2x cubed, that is degree of polynomial, okay? And then other important term is leading coefficient.
Leading coefficient.
So leading coefficient is new term for you. Let's say coefficient of each term. So these numbers are the coefficients of each term. Do you see?
Yes.
This is a constant. This number is a constant. Do you understand? This is how we identify each term in a polynomial. We can address them. So what is 7? So example, 7 is coefficient of,
X.
what is coefficient of x square?
X squared 3
Minus 3.
minus 3.
Minus 3. Do you see that? Negative 3. The whole thing has to be taken, correct? However, 2 is the leading coefficient, the coefficient of highest power. So leading coefficient is coefficient of highest power. Is it okay?
Yes.
So in grade 11, you will understand how to graph these polynomials and refer to leading coefficient, which gives you the behavior of the function itself. You get the idea?
Yes.
Therefore, it is important. Let us try to visualize it now. Is it okay? Now, how does the degree matters? I will show you this and then we'll get into polynomial division. Is it okay?
Okay.
Okay. Now, we'll seek a polynomial. Graph with degree. Okay. So, I could write a polynomial. Let us say y equals to 5. Is it a polynomial?
No.
It is a polynomial. It has a degree of 0. This could be written as 5x to the power of 0. Do you see that? It is a constant. And constant is also a polynomial. So many students think it is not a polynomial. Is that clear to you? If I have to
Yes.
graph this, then how will I graph it? So let me graph it in this color itself. It has a degree, and that is my graph. It is the only polynomial whose graph is a straight line, horizontal line. You get the point? So this is the
Yes.
line which is y equals to 5. It is the only polynomial constant, which also is exceptional, which is not a curve, right? Now, I have the polynomial y equals, this is a horizontal line. This is a constant, which is a horizontal line. Do you see that? Only polynomial with a horizontal line, okay? Where the slope is constant. Slope or gradient is 0,
Constant.
0, I should say. Gradient 0. You understand? Now,
Yes.
if I write y equals to half x, now is this a polynomial?
Mm.
Let me change the colors. We'll use different colors. So I said slope constant means, this means slope is slope m equals to 0. Is it okay? Now,
Yes.
I'm writing another polynomial which is y equals to half x. Now, how will it look like? It is a straight line, correct?
Yes.
So this is line which is y equals to half x. This is also a polynomial, and here the degree is what? 1. X to the power of 1. You get the idea?
Yes.
It has a constant slope. It has a constant slope. Constant slope, and m is equals to half this time, not 0. Do you understand? So both have
Yes.
constant slope, but with 0 slope, this is horizontal line. Is that clear? And this is diagonal line. Is that clear to you? Now, let's
Yes.
look into another polynomial whose equation is going to be y equals to, let us say, minus 2x square. Now, x square is always positive, correct? The square of any term is positive, right? But
Yes.
if you multiply with negative, then it becomes negative, and therefore it could be like this. Do you see this?
Yes.
Now, this is a polynomial. It is a smooth curve. Do you see that? Parabola. It's called parabola. Correct? And has one turning point like this. Do you see that? Now
Yes.
here, This is a degree what? Tell me. Its degree is 2.
Square.
And leading coefficient?
2.
Minus 2 is the leading coefficient. You get the idea. Don't forget the sign. Now, let's move forward. And now let's take up another polynomial. And I'm saying this is y equals to, I'm making things simple, okay? Y equals to, let's say 3x cubed. Now, when I say 3x cubed, now what is the degree? Let me make it 13x cubed. What is the degree? 3. X power is 3, right? And
Yes.
leading coefficient?
13.
13, correct. And the graph may look like something like this. They are not to the scale. Do you understand like this?
Yes.
So all the polynomials will have different kinds of graphs, and I could have some smooth curve which is like this also, which could be written in different form, and we could have this as like x plus 5 times x plus 1 times x minus 4. Do you see that? That could also...
I didn't understand one thing. How did we get to do this graph? Like, how did we get to know this is diagonal, this is curved?
Okay, use graphing calculator. You know lines, you have understood line, correct? You have done lines. So first
Yes.
two are good for you. You also have learned parabolas, you know factoring, correct? Do you know factoring?
Yes.
Correct.
Yes.
But the teachers did not teach you what you are factoring. I am telling you that it is a parabola, correct? And what factoring means, I'll show you now. I'll show you. Okay. Now let's move further and then understand, have a good view of these polynomials first, right? So how factor relates to polynomial? Do you understand? This is my next question. You have done factoring, correct?
Yes.
So in learning mathematics, you have to relate what you have learned, correct? I'll tell you
Yes.
how it relates, okay? For example, you have this factored form of y equals to, let us say, x plus 1 times x minus 1. What is this equal to? Tell me.
5.
X square minus 1. This is difference of square, right? When you multiply, this is what you get. Do you remember that? You remember the
Multiply.
formula?
Yes.
Correct?
Yes.
You also remember what is x plus 1 whole square? Let's say x plus 4 whole square. Let me make it simple. Not 4, but let's make it x plus 2 whole square. Tell me, what is this equal to? X square plus
X squared plus
4x
4.
plus 4, right?
Yes.
And if I write x minus 1 whole cube, then what is this equal to? A cube minus
plus
3x
minus
square 1, right? Plus 3x 1 square minus 1. This is your cubic equation, right? All three are polynomials, correct? You get the idea?
yes.
All three are polynomials. Let me show you. And their factors. These are the factors. I have written what? I have written polynomials in factored form, right?
Yes.
So what you need to do is use graphing calculator. To relate factors and x-intercepts. You will understand, and also behave and many other things. Is that okay? But let me today, in short, give you an idea before we get into our major class. You get this? So when I say it is first one, which is a parabola, in that case, I could actually sketch it like a function. It will look like this on a calculator, graphing calculator, where these points will be -1 and +1. Do you see this?
Yes.
This is, I'll call graph number 1. So these factors really mean they will give you zeros. If I write x equals to 1, you'll get 0, correct?
Yes.
0 remainder. So when you write factor, value, then what you get is a 0, right? So we have a 0, right, at x-intercept, right?
Yes.
So if I divide by that number, I mean, you understand that number is going to give me a remainder 0. In this equation, if I put x equals to 1 or minus 1, I'll get a 0 y, right? So dividing is related. I'll just show you that. So if I divide x plus 1 times x minus 1, right? This value of y, then the remainder, if I divide this by, let us say x plus 1, what is the remainder? I get x minus 1, right? Remainder 0. Do you see the remainder 0? Because they cancel,
Yes.
I get x plus 1, no remainder. We'll learn this soon. But this is how it is connected. Is that clear to you? So these
Yes.
factors, if you have a factor, then when you divide, you get 0 because that is my x-intercept. Now, second graph, x plus 2 whole square. Let me graph that also. Second graph is x plus 2 whole square. So that will be a parabola which will look like this, where this point is minus 2. Because if I substitute minus 2, will I get 0 here? Minus 2 plus 2 whole square is what? 0. Do you see that?
0.
So I
Yes.
get x-intercept at this point. The graph will be like a parabola shown here. Now, if I draw a cubic equation, which has a 0 at which point? It has 0 at x equals to 1, right?
Yes.
It has a 0 at x equals to 1, right? So at x equals to 1, it has a 0. And if I write 1 here, 1 minus 1 is 0. So that is why x equals to 1 is a 0. And at x equals to, let us say, plus 2, at x equals to plus 2, if I write plus 2 here, then I have one value, right? And if I write here 0, then we get minus 1. So basically, it is a graph which is kind of like this. Do you see this graph? This is your
Yes.
third graph. So you can relate your equations with the graph and they look like this. These are polynomial functions. Is that clear to you now?
Yes.
Now let's get back to polynomial division. Is it okay? You understand polynomial. Now we'll talk about polynomial division. So first case we will take when we are dividing by a monomial. Monomial means only one term. Is that okay?
Yes.
We are also talking about single variable. Is that clear to you? So we could
Yes.
take examples like what? We could take examples like 2x squared divided by, let us say, 3x. We could take examples like 5x to the power of 4 minus 3x squared plus x divided by, let us say, 2x. Is that okay?
Yes.
So if you divide these monomials by monomial, then in that case, if the powers are, if in this case we are taking case 1, where the power or the degree of denominator is lower. Do you see that? Degree of denominator is lower.
Yes.
Then all the terms. Do you see that? In that case, we will not get any remainder. Is that okay?
Yes.
So in this case, what do you get? So we have degree of denominator. All the terms in the numerator. All the terms in numerator. So the lowest one is 0, which is saying 1 is matching, right? You know, degree of denominator is not greater than, lower than or equal to, right? It can be lower than or equal to, right? Lower than or equal to. Or
Can you just wait for a moment? I'm not able to hear you properly, so I'll just change the connection.
sure.
Yes, just a second. Can you hear me?
Yes. Is it okay now?
Yes.
Okay. So if I do the first one, 2x squared over 3x, when I divide, what you get is 2 over 3, the simplest form of the coefficients, correct? And
Yes.
x squared divided by x is x. Do you see that? Now, in this case, what do you get? Each individual can be divided by 2. So we have 5 by 2 and x to the power of 4 divided by this will give me x cube minus 3 by 2x plus 1 by 2. Do you see that?
Yes.
That is what we are going to get. Now, these are, whatever you get here are quotients. Here, remainder is 0.
Okay.
Let's go to the new page to understand these new terms, right? So you remember when you divide some number, let's say 7 divided by 5, 5 times 1 is 5 and you get remainder 2. Do you see that? So in this particular case, you know, this is called divisor, right?
Yes.
This is called quotient. This is called,
Divider.
and this is remainder.
Yes.
So dividend. So we could actually write this in many different ways, correct? We are saying that we could write this as 7 times, oh sorry, I was writing 7, I wrote 2. Okay. We could write this as 7 is equals to 5 times 1 plus 2, correct?
Yes.
That is to say dividend equals to quotient divisor times quotient plus remainder. Is it okay?
Yes.
We'll also write this in another form, which is dividend over means 7 over 5. We could also write this as this form. Let me rewrite in different color. 7 over 5 is equal to 1 plus we still have to divide 2 by 5. Is it okay?
Yes.
So this is called division statement. So we write this as dividend divided by the divisor is equal to quotient plus remainder over divisor, correct?
Yes.
So of course, divisor is not equal to 0, right? So here we have a condition and that is divisor not equal to 0. You cannot divide by 0. Is this all clear to you? This is
Yes.
normal, right? We cannot divide by 0. Now, everything works in polynomials also. So what I'm trying to say here is, you understand this, we'll connect this with polynomials. You understand now?
Yes.
Correct. So this long division we are connecting with the polynomials. Is this clear to you?
Yes.
Very good. So now let's take up the examples which we just took. So let us say now we are going to divide a polynomial using this division form. So I'm writing here 15x to the power of, let us say, 4. And I'm going to divide this by 3x squared, right? So which you are familiar with like this also, 15x to the power of 4 over 3x squared. Is that clear to you?
Yes.
Now look here. How many times will 3 go into 5? This is what we have to first consider. 15 over 3 is 5. So we'll write 5 here. Is that okay?
Yes.
And how about x squared over x to the power of 4 over x squared? It is x to the power of 2,
X
right? Exponent
squared.
rules.
Yes.
Is that clear to you? So that is
Yes.
my, and what is the remainder? If I write 15x to the power of 4, I get remainder 0. How did I get 15x to the power of 4? Because I multiplied this term with this term. So
Yes.
I had 3x squared times 5x squared, right? Which gave me 15x to the power of 4, which I wrote here. Is that clear to you?
Yes.
And then when we subtract, we get 0. So in this case, that is my remainder. Is that okay?
Yes.
And therefore, I could write this as 15x to the power of 4 divided by 3x squared is equal to 5x squared plus 0 over 3x squared. Now here, this is my quotient. Do you see that?
Yes.
And that is my remainder. And this is called division statement. Is that clear to you?
Division statement. Yes.
Correct. That is how we will do. You could also do this using factors. Correct? So let's see how do you do it using factors. Let me show you with factors also. Is that okay?
Yes.
So 15 x to the power of 4, we have to write in terms of 3x squared. 15 is what? 15 is 3 times 5, right?
Yes.
And x to the power of 4 is x squared times x
Square.
squared, correct? We are dividing
Yes.
by 3x squared, and we could actually cancel the common terms. What do you get? You get 5x squared. You see that? Same answer. So you could get the same answer by factoring also. So what I have shown here is two different ways of dividing. One is called long division. And this is using factors. Is that clear?
Yes.
Now let's move on and take more examples. So this time I'm taking an example like 10x to the power of 4 minus 6x cubed plus 2x squared minus x, and we are going to divide this by, let us say 2x. Is that okay?
Yes.
Now, since we have the same degree, what is the remainder for me? What do you expect remainder?
2 and 5.
Zeros.
Quotient.
Because we have the same degree, correct?
Yes.
Now let's start. Do you understand this part, right? So we expect a 0 remainder in this case since the degree of numerator denominator is same, right?
So, yes.
If the degree of denominator is low, I mean, if one term is lower, then we have, now let's go through it, right? So first term, we have 10 and 2. It will go 5 times, right?
5 times.
And x will go how many times? X cubed. Do you
Square.
understand? So laws of
Yes.
exponents apply. So you get 10 x to the power of 4. This is 0. We bring down the next term, 6x cubed. And when you divide, this goes 3 times. And x will be square, right?
Square
You get
times.
minus 6x cubed. And then we bring in, this is 0 plus 2x squared. And this will go 1 time.
1 times.
We do not write 1, but we can write x here. You get 2x squared. When you take away, you get minus x. And this will go minus half time. Do you see that?
Okay.
So we get minus x, remainder 0. Is that okay? So
Yes.
now we know what the quotient is. So now we know that the quotient Q is 5x cubed minus 3x squared plus x minus half. You see, it is sum of all the terms, correct? You could also do this by factoring each term. So all this is your long division method. Is it okay?
Yes.
Now let's do this factor. Factor kind of simplification, we will now write this as 10x to the power of 4 minus 3 or 6x cubed plus 2x squared minus x, right? Each term can be now divided by 2x. Do you see that?
Yes.
Think like this. And what you get is the result. You get the idea?
Yes.
So you could do like this also. So far, it is not so difficult. Now let's take examples where we have a factor. Let me still go ahead with, let me clear the screen. We'll now divide by binomial. We are still considering remainder 0. So when I say remainder 0, then that means there is a common factor. Do you understand?
Yes.
So what I will do here is you have to factor and then figure it out. Let us say if you multiply, let's say y equals to x plus 3 times x plus 2, what do you get? First expand. Tell me what you get.
X square x
X square
square
plus
and
2x
x
plus
2x 3x and
6
6
plus 5x plus 6.
5x plus
That is what you
6.
get, correct?
Yes.
Now let's say what is the question on division, right? So my question here is you have to divide x square plus 5x plus 6 by x plus 2. What will you get?
Mm.
So let us do it. So we could write this as x square plus 5x plus 6 divided by x plus 2, correct?
Yes.
So numerator can be factored as I had shown you, right? X plus 3 times x plus 2, correct?
Yes.
And then when you divide by x plus 2, then what happens? X plus 2 cancels, and what you get is x plus 3. Do you see
Plus
that?
3. Yes.
Do you understand? So what I'm trying to show you that this number is equal to x plus 3, correct?
Yes.
Remainder 0. So this is the quotient. And remainder equals to 0. Do you see that? Because that is the meaning of factor, correct? The remainder should be 0, right? Now,
Yes.
so what we have seen here, that when you divide, you get this expression, correct? So let me rewrite this x squared plus 5x plus 6 in a new page, and let's try to understand it. X squared plus 5x plus 6, we could factor this. How will you factor this? Sum and product, right?
Yes.
You remember? So we want a product of two numbers p and q as 6, right? And we want the sum of these two numbers as 5, correct? So the
Yes.
two numbers which will work for you are 3 and 2, correct? 3 times 2 is 6, and when you add, you get
6.
5. So I could now write this expression as x squared plus, this is split into 3 and 2, right?
Yes.
And then you can factor, x is common here, we get x plus 3, and 2 is common here, we get x plus 3, and then x plus 3 is common, and we get x plus 2. Do you see how we are connecting?
Yes.
So connecting, this is what we call, whenever we do math, we have to connect our learnings. Are you reminded? Can you recall this? You
Like
learned this
explain the
earlier, right?
sum? Yes, we learned this earlier.
Good idea to collect. That is how it is. Now look here. I am writing here what? I am writing here an equation, and the equation is that x squared plus 5x plus 6 is equal to x plus 3 times x plus 2, correct? Is it
Yes.
okay? I'm saying that,
Yes.
correct? So this is my statement. Now what does it mean? It means that, let us say this is y, right? Let's say this is a polynomial y equals to this. Is that equal, right? Let us say this is my polynomial y, okay? It means,
Okay.
it means what? It means that x plus 3 is a factor of y, correct? So
Yes.
that is the product. This is called the product, correct? And these two are factors, correct?
Factors.
And it means that x plus 2 is a factor
Of
of y. This
y.
is what you did. So this is factoring. So I'm not saying you anything new. I'm just telling you what you learned. Factoring means to write the polynomial in terms of its factors, correct? So
Correct.
these are the two factors. Now, if I interchange, now look at how division, how this relates to division. If I say x squared plus 5x plus 6 is divided by, let us say this time, x plus 3, what do you get? You get x plus 2, right? If I divide the left side by x plus 3, both the sides, then I get x plus 2, correct?
Yes.
Do you see division?
Yes.
So that is how the division is related. So when very clearly you observe how all this gets connected, correct? So let me just give you this example once again, x squared plus 5x plus 6, right? So what we wrote here is x squared plus 5x plus 6 is equal to x plus 2 times x plus 3, correct?
Yes.
I could write this as a division statement. In mathematics, a statement means what? Statement means an equation. Do you see that equal to sign?
Yes.
A phrase means an expression. Correct. Statement means an equation. You get the idea? So this is a division statement. How I will write this as a division statement? Look here. I'm writing x squared plus 5x plus 6 divided by x plus 2 as equals to x plus 3. It is a division statement now. Do you see that?
Yes.
I could also write this as x squared plus 5x plus 6 divided by x plus 3 as equal to x plus 2. Is this same thing? Do you see both as the division statements?
Yes.
So both are division. So I converted the multiplication statement
To division.
Can you understand what all you are learning? You are learning this. You get my word? So when
Yes.
the remainders are 0, we could straight away write our multiplication and division statements interchange. Do you see that? Correct?
Yes.
That is what you did. So why were you factoring? You were factoring so that you could cancel and write down the quotient very easily. This becomes your quotient, right? So in
Yes.
both these cases, what you have is a quotient. So this is a quotient, that is a quotient. Do you see that?
Yes.
When you divide, now we will take a case where there is a remainder. Is it okay?
Yes.
Let me clear this. And let me take a simple case. I'm writing here. Now this time, x, we'll keep it x cubed plus 3x squared plus, let us say 6x minus 5. Okay. Let us say this is my division. And I have to divide this by, let us say, x plus 1. Is it okay? So now we are
Yes.
dividing by a binomial, a cubic equation. So when I do that, in that case, we have to take care of x and x cube first. Is it okay? We'll take term by
Yes.
term. So when you divide x cube by x, what do you get? You get x squared, right?
Square.
Since there are two terms, we are going to take two terms to divide. Now, we have x squared in the quotient. Multiply x squared with both the terms, we get x cubed plus x squared, correct?
Yes.
Now you take away. That is the division process, right? You understand?
Yes.
So when you take away, then what do you get? Well, this time you get, this is 0, but here you get 2x squared, right? And then you bring down the next term, which is 6x. Do you see that?
How did we get the 2 square?
3x squared minus x squared. We'll difference this, right? We'll take away this. That is division, right?
Yes. Okay.
X cube minus x cube is 0.
0.
And 3x squared minus x squared is 2x squared.
Yes,
Now you
I
bring
got
down the third term. So now this becomes your new dividend. Do you see this new dividend?
Yes.
Follow the process. So x will go in how many times? In 2x, right?
Yes.
Why did we get 2x? Because 2x squared over x is what? One of the x will cancel, you are left with 2x. Do you see that?
2x.
Now you multiply 2x with x plus 1. What do you get? 2x squared
Square
plus 2x, right?
3.
So you write down here 2x squared plus 2x. Is that okay?
Yes.
Now again take the difference. When you take the difference, this again becomes 0, right? And what is this? 4.
4.
X minus 2?
4x.
4x. And now bring down the next term, which is minus 5. Do you see that?
Yes.
Now this becomes the new dividend, right?
Right.
So dividends change, but the divisor is same, right? Now, how many times will you multiply? X with 4.
Of 4 the
4x plus 4, right? And
yes.
when you take away, what do you get? Minus 9. Do you see you
Minus
get a
9.
remainder of 9? Minus, correct? This time we got a remainder. So here we could write this as x cubed plus 3x squared plus 6x minus 5. When you divide by x plus 1, what you get is the quotient, which is x squared plus 2x plus 4. And there's a remainder, which is minus 9. And we still have to divide it by x plus 1. Do you understand now?
Yes.
And in this example, we get a quotient, which is x squared plus 2x plus 4. And we have a remainder, which is minus 9. Is it okay?
Yes.
Don't forget negative term. So that is the remainder. This is what the division is. You get the idea?
Yes.
So that is your remainder, and this is your quotient and remainder. So you might get remainders. If you get remainder, that means x plus 1 is not a factor of this cubic polynomial, right?
Yes.
Till now, the examples which we took, they were all the factors. Is that clear to you?
Yes.
That is the long division method which you should adopt when we have binomials to be divided and you cannot factor completely. Is that okay?
Yes.
It's difficult, otherwise you can do it. I'm not saying you cannot do it, and you have many examples in your book. You can follow those. However, this is a standard method which you should follow for now. Is it okay?
Yes.
Is it clear to you?
Yes, totally.
We'll stop our class here. So I've stopped sharing the class here. Can you now summarize what have you learned in today's lesson?
Yes, we started with polynomial bar graphs, and then how to identify a polynomial, like even two variables can be a polynomial that we given, and then how to factorize in non-division
Okay.
and mistake.
So we actually started from the very beginning. the chapter was on dividing polynomials. We understood what are polynomials, right? So in polynomials,
Yes.
we have sum of terms like ax to the power of n, where n is non-negative. It cannot be minus, it cannot be even half. It is a whole number, right? So
Right.
if we have this polynomial written to us, we also understood that it should be written in a standard form. Writing in standard form means highest power terms come first. So in decreasing powers of the terms, we write them. The term with the highest power is a very important term. The exponent there gives you the degree of the polynomial, and the coefficient is the leading coefficient. Is that okay? These are very important terms, leading coefficient and that. So we understood what polynomials are, how should we write them in standard form, and then we divided polynomials by monomials, and we understood that in many cases we do not get any remainder if the divisor's degree is lower than all other terms, right? It's not greater than all other terms in the numerator, right? Then, if, however, the divisor degree is higher than the lowest term, the last example which we took, there was a constant, right? So the constant degree is 0, and we are dividing by linear x plus 1. So therefore,
Yes.
that constant will result into a remainder. Do you get the idea?
Yes.
So because there was one term which is a lower degree, we cannot divide that, and that will remain to be divided. That is called remainder, remain to be divided. And therefore, in our division statement, we write that remainder divided by the divisor. Is that okay? And you
Yes.
also understood the long division process, where the dividend changes in each step. Divisor remains the same, correct? And then finally, you get the quotient and the remainder, and you now also understand how do we connect the division statement and the multiplication statement when we are dividing polynomials. Is that clear to you now? Try some
Yes.
questions from your book, and I hope that helps. Okay? And
Yes.
all the best. Will further continue. If there are any difficulties, be in touch. Okay? Share
Yes.
all the problems. Thank you. And all
Bye.
the best. Thank you. Bye.